Today's lesson is on transformations of quadratic graphs. So don't write this part down, but you probably remember earlier in the year when we were graphing absolute value. And we started with the basic one, and then we had to shift it right, shift it up. So similar idea, we're using the vertex form of a quadratic that we've been learning about. And now we're going to graph when it's in this form. So first starting, parent function is the most basic quadratic, which is y equals x squared. So 0 squared is 0, 1 squared is 1, negative 1 squared is 1, 2 squared is 4, 3 squared is 9. So this graph is the parent function. Now, when we have something in vertex form, let's say y equals a times x minus h squared plus k. So when it's in this form, it tells us how to shift our parent function. So inside the parentheses, it will tell you how to shift right or left. And then the number at the end tells you how to shift up or down. And then, so this is the h, the k, and then the a tells you if you're going to stretch your parabola, or if you're going to compress your parabola, or flip your parabola. So it tells you basically how skinny, how fat, if it's opening up or if it's opening down. So if let's just say I have y equals, I'm going to have no a value, or just a value 1 this time, x minus 2 squared minus 3. This one tells you to shift right 2, down 3. So just like when we were doing absolute value, inside the parentheses is opposite. So when you have minus, you're shifting right. Now, when we go here, all we're going to do is shift all of our points right 2, down 3. Do that with all the points. Right 2, down 1, 2, 3. Right 2, down 3. Right 2, down 3. Right 2, down 1, 2, 3. So I know there's lots of lines on here. Normally we're not going to actually draw all those lines, but I'm just showing you. Right 2, down 3. If we shift all of our points right 2, down 3, now what we have is this parabola. It's just been transformed using vertex form. Okay, so let's do some other examples. First one, y equals 2 x plus 4 squared plus 1. So starting out, we're going to find our vertex. So plus 4 on the inside, it's opposite plus 4, you think right, but it actually is left. And then on the outside, it's not opposite, exactly what you think it's going to be up. So my vertex is going to be at negative 4, 1. So negative 4, 1, 2, 3, 4, up 1. If that is my vertex, then I have my axis of symmetry that goes through my vertex. Okay, this value right here, that coefficient, one little trick is, think rise over run only works one time. That rise over run 2 over 1 only works to get the 2 points from the vertex. So up 2 over 1 and reflect it. We cannot continue that for other points. If we're going to get other points, we need to make an XY table. So let's just pick a number close to that axis of symmetry. Let's plug in negative 2. So when you're plugging it into your function, I've got 2. I'm plugging in negative 2 plus 4 squared plus 1. Okay, so now I've got 2, positive 2, squared plus 1. 2 squared is 4, 4 times 2 is 8, and 8 plus 1 is 9. So I have this point -2, 9 right here, reflected over, and now I've got my parabola. Okay, let's do one more example. Y equals negative, so that's like -1, x minus 3 squared plus 5. So inside the parentheses, minus would be to the right, plus 5 would be up. And then, so our vertex is at the point 3, 5. So let's graph that. Right 3, up 1, 2, 3, 4, 5. So wherever my vertex is, my axis of symmetry cuts right through the vertex. And then A is -1. So you can think of that rise over run, -1 over 1. You can only do that one time, and that's from the vertex. So I'm going to go down 1 over 1 and reflect it over. Okay, let's use XY table, and let's pick a number. Let's pick 1. And then let's look at our function. So 1 minus 3 squared plus 5. 1 minus 3, -2 squared plus 5. So this goes to 4, but then this goes to -4 plus 5 is 1. So all of this is 1. So we have the point 1, 1. Let's do one more. Why not? Let's plug in 0. So -0 minus 3 squared plus 5. So -3 squared plus 5. So this is 9, but then it's negative. So this would equal -4. So 0, 1, 2, 3, 4. Reflect that over. Oh, I never reflected this one over. And there we go. Here we have our parabola. So there is your video on graphing quadratics when they are in vertex form, shifting up, down, right, and left, and finding some points. Good luck.